Hello, welcome to Flipped. So today we are on atomic structure, and it's really all about the atom. An atom is really the smallest unit of an element, which is, for example, carbon, calcium, fluorine. Okay, anything that can be found in the periodic table are called elements. Okay, and it's made up of atoms. And atoms can be further divided into three subatomic particles. Sub means to be part of, right? So subatomic means part of atomic. Okay, means whatever atoms can be broken down into these three things: proton, neutron, and electron. And these are their relative mass and charges. Proton has a mass of 1 with a charge of plus 1, so it's positive. Neutron is 1 with a charge of 0, so it's neutral. Electron has a charge of minus 1 with a mass of 1 over 1840. So this is a very, very small number. It's 0.00 something. And so you can see that proton has a positive charge, electron has a negative charge. And so they cancel out each other. Okay, this is something very important that we have to keep in mind for a later part. Okay, let's move on. So this is the structure of an atom. Okay, basically you put the protons and neutrons at the center. It's called the nucleus. Okay, this one is the nucleus. Okay, you can see that this is the nucleus. This is the first shell. This is the second shell. Okay, what do shells mean? Basically, electrons orbit the atoms in shell. Basically, so electrons will take up the space around the atom on these circular shells. Okay, it's something like when you have the Earth orbiting the Sun and Mercury and etc. other planets. So it's the same thing. Okay, they orbit around the nucleus. So basically, if the shell is closer to the nucleus, for example, the first shell, okay, it has lower in energy and it's smaller in radius. So you can see that the first shell is smaller than the second shell in radius, correct? Whereas the further shell, for example, in this case, the second shell, has higher energy and bigger radius. Okay, and atoms are electrically neutral. Okay, this is because the number of electrons is equal to the number of protons. This is very important. Okay, and the positive and negative charge will cancel out each other. So let's take a look at example of a lithium atom here. You don't have to know how to draw this at this point of time. Just have to bear in mind. Just have to take a look at the structure. So you can see that I have 3 protons here and 4 neutrons here. Correct? So this one represents proton, neutron, and electron. So you can see that I have 3 protons, 4 neutrons, 3 electrons. And all my protons have a plus 1 charge, correct? And all my electrons have a minus 1 charge. So you can see that this is plus 3 total, this is minus 3. So plus 3 with a minus 3 gives us a net neutral charge, okay, which is 0. And that's why they say that atoms are electrically neutral. So this is very important. Okay, this is the chemical symbol which we will learn about next. Okay, so now we have the atomic symbol. So this one, there's a difference between what is being taught and what is being given in O-level syllabus. Okay, let me explain that in a while. Let me explain about this one first. So basically, I have 2 formulas for you to memorize. First one is nucleon number, which is basically the number of protons plus number of neutron. So please take note that there's a difference between nucleon and neutron. Okay, nucleon is a bigger thing. Neutron is one subatomic particle. Let me explain. Okay, so back to this. If you recall our diagram here, this is the nucleus, and hence this is the nucleon number. Okay, basically, let me repeat that again. This is the nucleus. All right, I just draw it in a circle to show that it's the same thing. This equals to this thing. It's the same thing. Okay, nucleus. Okay, nucleus. The word nucleus is very close to the word nucleon. Okay, and that's how we got the name for nucleon. Okay, nucleon. Let's bear that in mind. Let's move on down here again. So nucleon number is really just proton plus neutron. Okay, so neutron and nucleon, please do not be confused between them. And really, this is really just a mass number. Okay, and the mass is determined by protons and neutrons only. Electrons, we do not take them into account because they are too small. Okay, because let's go back to here. Okay, you can see that proton and neutron has a mass of 1 each, whereas electron has a 0.00 something. Okay, so it's really redundant to count electrons in because they are so small. So we really only take proton and neutron into calculation for the mass. Okay, and hence we are here. Okay, you can see that this is my chemical symbol. For example, X. Okay, X can be anything. For example, from sodium, magnesium, etc. And this is the nuclear number that we're talking about here. Okay, which is the mass number, how heavy this atom is. Next one is about the proton number, which is this one, B. Okay, proton number is really just the number of protons in atom, okay, in the nucleus. And this is equal to the number of electrons, like we mentioned earlier, because all the plus charges, okay, has to be cancelled out with a negative charge. Okay, if not, it will not be neutral, and we want it to be neutral in an atom. Okay, so basically, the third one is not really a new thing. Okay, it's something from the first one. So remember I told you there's two equations to memorize. This is number 1. This is number 2. Okay, this is actually from equation 1. This one. Why do I say so? Because neutron number here, let me just highlight them both in red maybe. Neutron number is here, right? So basically what you want to find this guy here, what you do is you shift the proton here. Okay, and what do you get? You get nucleon number minus proton number. And that's why you get neutron number from this equation, which is the same as the first one, just that you shifted the proton back here. Okay, hopefully that's clear. And basically different elements have different P and E number, which is proton, neutron, electron. So let's take a look at, for example, sodium. Okay, this is Na, right? And I have I'm copying this directly, and I'll show you what's the difference between what's being taught and what's the difference between what is being taught in school and O-level syllabus. So you take a look here. This guy, okay, is 11. This guy is 23. Based on this equation, you are inclined to say that this is the mass number, this is the proton number. But this is not correct. Because nucleon or mass number is always the bigger number. It has to be, right? Because nucleon number is made up of proton plus neutron. Whereas proton number is just proton. So this one is a smaller number. So it's actually being flipped right here. Do you see? And you can see that this one has to be the nucleon or mass number. Whereas the smaller one is the proton number. Okay, so please do not be confused when you refer to the O-level periodic table, which is this one, and what you are being familiar with. Okay? But anyway, let's using this one. Once we sort it out, it's quite clear anyway. We can see that proton number is 11, correct? Electron number has to be the same number as proton, which is also 11. So neutron number, which is nucleon minus proton, will give me, which is 23, minus 11 gives me 12. Okay, and that is the answer for proton, electron, neutron. 11, 11, and 12. Okay, hopefully that's clear. So you really just have to memorize these two equations and know what do these two mean. Okay, so basically these are the three main takeaways from this slide. This one, and this one. Knowing that the mass and nuclear number is the bigger one than the proton number. Okay, next is about isotopes. So basically we have seen that different elements, different elements have different number of protons, neutrons, and electrons, etc. But what if I have an atom, okay, that two atoms basically having the same number of protons and hence same number of electrons, because positive has to cancel out negative, but they have different number of neutron, okay, and hence different nucleon number, correct? Because nucleon is made up of neutron and proton. So if my neutron changes, nucleon will change as well. Okay, hopefully that makes sense. So basically, isotopes, in short, are just atoms with different neutron number. Let's take a look at A, B, C. So you can see that A has 4 protons, 5 nucleons, 4 electrons. Okay, the rest you can see for yourself. But you can see that they have the same number for protons in terms of A and B. So these two are the same. But this is different. Do you see? Okay, same number of proton of 4, but nucleon is that A has 5, B has 4. So this one obviously fits into the criteria for being an isotope. Okay, and hence A and B are isotopes. Okay, so you can say that A and B are isotopes. Okay, whereas C is totally out because the number of protons are different already. from A or B. So you can just strike it out. Okay, it doesn't play a part. It's a different element altogether. So how do we illustrate? How do we write down A and B? Let me just write it for you. A, this is B, right? In terms of chemical symbol. So A has, proton number is always below. So A has 4, B also has 4. Correct? The mass number for A is 4 plus 5, which is 9. Because remember, nucleon or mass number on top is number of neutron plus number of proton. Whereas for B, it's 4 plus 4. So it's 8. Okay, so please recall that in our chemical symbol, atomic symbol, we do not include electron number at all. This is just proton number, which is anyway equals to proton number anyway. So you don't have to represent electron number. Okay, so this will be the atomic symbol you have to write for A and B. Okay, so what's the big deal about isotope? Basically, isotopes have similar chemical properties, means they react with the similar substances. Okay, for example, if A can react with water, B can also react with water because they are isotopes. But they have different physical properties. For example, A has a higher melting point than B, for example. Okay, so same chemical properties, different physical properties. Finally, we'll talk about electronic structure, which is really showing us how electrons are arranged in an atom. Okay, and this is because we know that electrons orbit around the nucleus, okay, made up of P and N. As in the nucleus is made up of P and N. But we do not show, we do not draw the neutron and proton in our electronic structure. Let me just show you very quickly. But first, we know that the first shell can hold 2 electrons. Second shell, 8 electrons. Third shell, 8 electrons. Fourth shell, 18 electrons. So what is here is actually 2.8.8.18. Okay, this one don't really make sense now. Okay, looks like a Morse code or something, but it's not. Okay, let me just show you in a while. And really, you have to fill electrons closest in the shell closest to the nucleus first. Sorry, this is wrong. This shouldn't be spelled like that. There's an additional U here. Okay, you have to fill the electrons in the shells closest to the nucleus first before filling the next outer shell. Okay, and the shell furthest away from the nucleus is called the valence shell, or the outermost shell, which contains electrons called valence electrons. Okay, let me just show you with an example, it'll be easier. So, okay, this is oxygen. Based on the periodic table I've drawn, okay, I've gotten 16O8. O is the chemical symbol, so I write it in the center. So based on this, I have 8 protons, and hence I know I have 8 electrons. So how do I fill in? I know my first shell can hold 2 electrons, so I'll put it like that. 1, 2. Correct? What's the balance? 6, right? So I have to put 1, 2, 3, 4, back to here, 5, 6. Okay, so I can see that my first shell has 2 electrons. My second shell has 1, 2, 3, 4, 5, 6 electrons. And hence my electronic configuration is 2, 6. Okay, that's what we mean. Okay, and that's why this is the maximum 2, 8, 8, 18. In this case, I just need 2, 6. Okay, this is the electronic configuration. Okay, let me just show you another example with sodium, maybe. Sodium is 23, Na 11. I can see that I have 11 proton now. Therefore, I have 11 electrons. Makes sense, right? What I do is I put Na at the center. Okay, let me just get more space. Okay, then I draw the first circle around it. And then I fill in the electrons. Maybe I need 2 in the center, right? Because the first shell can hold 2 electrons. 1, 2. And then the second shell can hold 1, 2, 3, 4, 5, 6, 7, 8. Correct? The second shell can hold 8 electrons here. How many do I need? 1 more, right? So I just need to draw 1 more here. Okay, and so you can see that it's 2, 8, 1. And this is my electronic configuration for sodium. Okay, hopefully that makes sense. So there's 3 shells here, whereas there's only 2 shells here in oxygen. Okay, and that will be all for atomic structure and electronic structure.